Hello and welcome to the 9th video in this series making simple Flappy Robin for the iPhone and iPad using Cocos2d. This video then we're going to make a start now in actually adding in our tube class so that we can actually put some tubes on the screen which the Robin then has to avoid, and this will be split sort of into two videos really, just so they're not massively long. This first video will add the class and add the definitions of the functions we'll need inside the intro scene to actually get the tubes working, and then in the next video we'll fill in the functions and actually add the graphics for the tubes and get them scrolling across the screen. So without further ado then, I want to go onto classes and right click and new file, Objective-C class, and I'm going to call this C Tube, and here it has to be a subclass, as I've already got in here, of C Cloud. So we're going to subclass our C Cloud class that we already have here, because we basically use exactly the same functions again, and we just need to add a couple of things into our tube class. So a little bit of handy reuse there, and something I didn't do in the C++ version for Android. I ended up making two completely separate classes, but tried to do it a little bit cleaner this way around. So I'm just going to be very lazy and copy a property from C Cloud here and drop this line then once, twice and three times into C Tube here. And the first property we need is something called an inactive X, because remember the tubes won't just continuously scroll whilst the game is running and when they've gone off screen be reset to the other side. They basically scroll once across the screen and then get set to what I will call an inactive X, which is way off the screen waiting to be reused again when they're required. So they work slightly differently to the normal flying objects across the screen. So we'll set a value for our inactive X. The other thing we'll need is an int, and that'll be the state. So the state will either be the tube is active or inactive. And the reason we have that is, you'll see later on, we'll maintain an NS mutable array of tubes. And when a tube has been created and set scrolling across the screen, rather than make a new object every time we want to get a tube to start scrolling across the screen, we reuse the object if there's one available. So once one has finished scrolling the screen, its state will be set to inactive. It'll be positioned at inactive X, which will be way across the screen. And when we need a new tube, the first thing we do is go through the array and see if any of them are inactive. Then if they are, start those scrolling rather than create a new one. So that's why we have the state. And the other thing we need here is something called scored. So has it been scored? And the reason for this is the tube is scored when the Robin clears the tube. And basically each update we go through all of the tubes and we ask the question, is the tube's X less than the Robin's X? If so, then increment the game score. But because obviously we're updating 60 times a second, then once the Robin has gone past a tube, then each update that tube will have an X less than the Robin's X, and theoretically would be scored. So we only want each tube to be scored once, so we set this flag then to true when it's actually been used to increment the score, and that will then never happen again. You'll see much later on in the application how that works. So those are the properties that we need then. And then I'm going to do a bit of copy and paste here, and I'm just going to copy the start, stop, reach, destination, initialize with speed, and override all of these because they're slightly different inside C Tube here. Like so. So if we go through them one by one, so with the start then we stop all the actions, but we don't need this current X here when we're setting the tube off. It will be at its inactive X, and in fact we'll reposition the tube inside this function. So the distance that it's going to travel is its X offset, which remember is the amount we want to let it move off the sides of the screen, multiplied by 2 for both sides of the screen, plus then the self dot the screen width. The time then is the distance divided by the speed, and the destination also stays exactly the same as it would for a normal C Cloud object. But now we want to set the position. So we'll say self and set position, and we want a point here, CG point, and the current position we want is self.x offset, then plus the self dot screen width, so it's off to the right hand side of the screen, plus the x offset, and then we'll just keep the current y position that stays all the time. The y is set on initialization of the tube. You'll see how that works when we start actually creating the tubes inside the intro layer. So that then sets the position of our tube off to the right hand side of the screen. Our action move and our action move done are exactly the same. What we do need to do, however, is we need to set the state. So self.state, and at the moment I'm just going to put a comment in there and a semicolon, and in fact I'll just put a 1 because that's not going to, we haven't actually made the constant yet. So I'm going to say self.state equals 1, like so. And the other thing we need to do is make the tube visible. So we'll say self set visible and yes, because our tube will be set to invisible when stop is called on the tube. And then all we need to do is run the action, and then reach destination will be called. So it's a little bit different to the C cloud. So the stop then, in the stop then we want to, after we've called stop all actions, we want to set the visibility now to no, as I'm just scrolling things a bit, so it's no longer visible. And then what we need to do is we need to set the state to an inactive. So I'm just going to, for now, leave the 1 there. We'll put a constant in there in a moment. And what we need to do then is actually set the position as well as the tube to its inactive X, so way off the screen, so it's not visible at all to the player. So set position, and we'll say self.inactiveX, so it's way off the left hand side of the screen. And we also then want to say self.scored equals false. So we can reset that as well, so that it'll be used to score next time it comes around in the game. This scored, like I said, you'll see when we start doing the game logic later on in some later videos. So that then completes the stop. So we stop its actions, make it invisible, set its state, which we'll do in a moment, and move it off the screen, set its score to false. And actually, inside the reach destination, we simply need to call the stop and not do anything else on there, because for the tube class, a bit different to the cloud class, because of the way it's handled or the way it's part in the game, we can just use the stop like this. So the other slight difference then is in the initialize with speed. So the self.speed is speed, the screen width is this, the X offset, what we're going to do is keep it as the boundingbox.size.width, that's okay. And the last thing we need to set here is a self.inactiveX, and to make absolutely sure we're way off, we're going to say it's minus self.screenWidth, which pretty much guarantees for each of the devices we're way off the screen and it's not going to be seen. So that actually completes the implementation of our tube class. It's not very difficult. And now what we can do then is we can go into constants and just add in some of the constants that we're going to require for the tube. So I'm going to go down the bottom of constants actually here, so we can sort of have the tube stuff collected. And the first thing we'll do is we'll define kTube state active as a 0, and then I'm going to copy and paste that and make it kTube state inactive and make that a 1. And before I do anything else, I'm going to go back into tube.m here and just import constants. And now I can say that here inside start we are kTube state active, and now I can say for the state inside the stop it's kTube state inactive. I'm just going to call build on all this and make sure it all builds. It does, because we won't actually see anything really running any different in this video. Back into constants then. And now we're going to add something that's slightly more complicated in this. The first thing we're going to do is add a new constant called k, and I'm going to call it kTube spawn min time. And this is the minimum time between tubes spawning. So it's going to be at least 2.3 seconds, which is a value with the speeds that the app runs that I found to make reasonable gameplay. We might change that later on. And I'm going to make another one called kTube spawn time variance, and that's 8. And that's then 8/10ths of a second. So what we're saying is that the gap between the spawning of the tubes will be anything between 2.3 and 3.1 seconds. And the reason for that is just to give a little bit of variation in the spacing between the tubes so that it's not all the same. So that's fairly easy to understand. We'll be using in the next video. Now we have a slightly more complicated thing. So I'm just going to type some constants out here, then explain what they are. So I'll say k single gap top, and it's 440, and we're going to multiply it by the y scale factor. And I'm just going to copy this now 3 times. And k single gap bottom, and this will be 230. And then k single gap max, and this will be 280. And then k single gap min, and this will be 160. Okay, so what are all of these then? Well, there are two types of tube, if you like, situation that the robin has to avoid. It's where one situation is where we have a pair of tubes, which I'll call a double, where one is at the top and one is at the bottom, and the robin has to get through the gap. The other one is where we just have one tube, either coming from down from the top of the screen and the robin has to get under it, or coming up from the bottom and the robin has to get over it. What we do, however, need to do is we don't want the tubes to appear at the very top or the very bottom of the screen. And likewise, we also need to leave a gap that the robin can actually get through. So what we're doing here is based on a 640 high screen, which is why I'm multiplying by this y scale factor for the iPad. We're specifying what the highest point is in terms of y that a tube, when it's coming down from the top of the screen, can be at. And likewise, when one's coming up from the bottom, what's the minimum y it's got to achieve. And then the gap from that tube to either the top or to the bottom of the screen, so what the robin can get under or over, is set as a maximum of 280, so that it's not too easy, but also a minimum of a 160, so it is possible for the robin to get over or under the tube. For now, you just have to trust the values there. I might change them later on when I've actually seen it running. It took a fair bit of playing around on the Android version. So, and likewise, we have them for the pairs, which I've called double. So we're going to have double gap top, double gap bottom, double gap max, and double gap min. And these values here then are 480, 120, and then 220, and 140. So that finishes off actually all of the constants that we need for the tubes. And now the last thing I want to do in this video is just go into the intro scene .m here, and I want to actually make some sort of skeleton preparation for the next video so that we can get ready actually adding the tubes into the game. So first thing we need is an NS mutable array, and we'll call this then the tube objects. And then down inside the initialization function here, just like we did for flying objects, we need to initialize our array. So I'll just call this tube objects here, and we'll initialize our NS mutable array so we don't get any crashes because we haven't actually initialized it. What we then need is we need some variables, and I'll put these variables underneath these arrays here. The first one we need, it's a float, and it's going to be called next spawn time. And you'll see how these work when we start programming logic next video, but this is just the time until the next tube should be spawned. We've got the last spawn time, so this was the time the last tube was spawned. So both of these obviously are used to say, okay, is it time to spawn the next one? And importantly here, we've got the last tube type. And this will store what type of tube was generated last time. And the reason for this is we don't want to repeat, say we spawn a tube from a single tube that's going top to bottom. Well, the next time we spawn a tube, we do not want to spawn another one of those, because you can end up with a whole row of the same type, one after the other, and that makes for very boring gameplay and very easy gameplay then. So we want to make sure that we always have a variation in the type of tube that we spawn. So we'll have last tube type stored here like this as well. And the last thing we need to do then is let's, at the bottom of the file below the add all clouds, let's start making the definitions of some of the functions. So we'll have set spawn time, which we'll use to set the spawn time for the next tube. we'll have spawn new tubes, which will be called when the appropriate time has elapsed to spawn the next tube. Then what we'll have is spawn upper or lower, with then a bool for is upper. So this is either to spawn an upper tube, so a tube coming from top down, or lower from bottom up. Then we want a function for when we're spawning a tube pair, which is where we've got sort of the double type. And we'll have, last but not least, the actual function that actually adds the tube to the screen. So spawn new tube, and this takes in a bool for, again, is it an upper, and we'll say at Y position, and that's float, and we'll call that Y position. So this is the function that will actually add the tube onto the screen and set it going. And last but not least, we need a function that gets us the next available tube. So we'll import into here then, I need this speech marks, our C Tube class. And then what we're going to do here is just, where's the function here? I'm going to say C Tube pointer, and this will be called get next tube. And what this function will do here is look through the current NS mutable array. I'll just put return nil for now. This will look through the NS mutable array of our our tube objects, our tube objects NS mutable array, and look to see if there's one in there that's inactive and return a pointer to that. If it doesn't find one in there, then it'll add one to the array and return the pointer to that. So that's it then for this video. That's the tube class then added, and some alterations done to the functions there. And then inside intro scene, we've prepared our variables and things we'll need, and we've also prepared the outline or definitions of our various functions we'll need, that in the next video we can flesh it out and actually add the tubes onto the screen. So I hope that made some kind of sense. Comments, questions, criticisms welcome as always on YouTube.